Hallo, it's dumplet here. Here's an item on algebra. P of x and q of x are quadratic polynomials with leading coefficients of 2 and -2, respectively. The graphs of those two have two common points, 1654 and 2053. We're asked to get the value of p of 0 plus q of 0. Credits to AIME of 2022, the American Invitational Math Examination, for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, we're already given that p of x and q of x, they are quadratic, and we know their leading coefficients, 2 and -2. So one way to get the p of x and the q of x is probably to realize that, okay, I know that p of x is going to look something like 2x squared plus ax plus b, and q of x is going to look something like -2x squared plus cx plus d. So quadratic with the respective leading coefficients. And I do have two given points, 1654 and 2053. So essentially, I'm just going to substitute the values into these two, and I just have to solve for a and b and c and d. So that's technically two different system of linear equations, and that's fine. But I think that's going to take a little bit long. And in fact, the values of a, b, c, and d, they're not really integers, so they are actually pretty bad. But it is doable. But I'm going to propose we're going to do something different. We're going to do a creative way to solve the question, and that's going to revolve around trying to set up how p and q of x should look like. Now, we're going to take advantage of the factor theorem, because let's take a look at the 2 points first. And I'm just going to focus on the specific x values. So it's 16 and 20. So let's just say we have a quadratic equation with those two as the roots. Obviously, it's going to be like x minus 16 times x minus 20. The leading coefficient of that is 1, but we want the leading coefficient of p of x to be 2. So I'm just going to say we're going to make it like this first, right? Again, it might not be obvious why am I doing this, but you're going to see things come into play later. Now, for q of x, same thing, x minus 16 and x minus 20. And, well, we want the leading coefficient of q of x to be -2. So that's not yet it, obviously, because so far, p of 16 and p of 20 is 0, q of 16 and q of 20, that's 0. So there should be something like after, somewhere here and somewhere here, that's going to help us get the desired values. But what's nice about having this thing in the front is that, well, if I substitute x to be 16 or 20, it's 0. And it's just really finding a way for us to write an expression for this one and to make p of 16 and q of 16 to be 54 and q of 20 and p of 20 to be 53. Now, well, again, it might not be obvious, but for the most part, we can kind of see that 54 and 53, they should come out of a certain expression here in the question marks here. So, and the thing we're substituting is 16 and 20. So, well, 16 and 20, they differ by 4. So I think it would be nice if there's like an x over 4 term that's going to differentiate the 54 and 53. Okay. Now, for example, if I substitute x to be 16 here, it's going to be 4. If I substitute 20 here, it's going to be a 5. And I could come up with this seemingly weird expression, 58 minus x to the 58 minus x over 4, and that's going to be 54 if x is 16, and that's going to be 53 if x is 20. And in fact, this is the thing that I'm going to add to two equations over here, and this is what I mean by kind of setting up. Again, it might not be obvious, but we could kind of realize that, well, essentially, I could just kind of find an expression such that this thing will hold, obviously. And it's not going to violate the stuff in the given because p and q are still quadratic because, well, this part's quadratic, right? This part's quadratic, but the thing I'm additionally doing, they are linear, so I could do that. So, and that's going to give us, I guess, a better way for us to write the p of x and q of x. And if you try to use this method, you would actually get the same thing. Okay. Now, now that we have this, the p of x and the q of x setup, I think it's really just a matter of substituting x in. Now, what's nice about this is that, well, this part, so the first part, the 2 times x minus 16 times x minus 20, and this part, well, they are exactly the same. No, they are opposites, sorry. They are opposites of each other. So I will get that if I add them up, if I add the two, I'll get p of x plus q of x. This middle part gets cancelled out. That should be equal to just 58 plus 58 is 116. And then 2x over 4s, that's going to be x over 2. And if I substitute x to be 0 here, I'll get that p of 0 plus q of 0, that's just going to be 116 minus 0 over 2. That's just simply 116, right? And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye!